The equation is 2 raised to the power of m plus 4 raised to m plus 8 raised to m equals 39. I am going to solve this equation, so follow me closely. We will try and write these exponential terms with a base of 2. We know 4 is equal to 2 squared, and 8 is equal to 2 cubed. Moving forward, recall that a raised to m raised to n is equal to a raised to n raised to m. We're going to use this on this term, and also this term. 2 raised to m plus 2 raised to m, then squared, plus 2 raised to m, then cubed, equals 39. To make this solution way easier, assume 2 raised to m equals to x for now. The equation becomes x plus x squared plus x cubed. And then let's transpose 39 to the left side and change the sign. So minus 39 equals 0. I'm going to erase the board because we got more solving to do. Next thing we got to do is to replace 39. Let's write first x plus x squared plus x cubed, and then replace 39 with 27 plus 9 plus 3. Remove the parentheses by distributing the minus sign to all 3 terms. We got x plus x squared plus x cubed minus 27 minus 9 minus 3. Let's proceed. And then let's express the integers as powers. 27 is 3 cubed, 9 is 3 squared, and 3 is simply 3. Let's rearrange the expression based on powers. X minus 3 plus x squared minus 3 squared plus x cubed minus 3 cubed equals 0. Moving forward, we're going to use the difference of 2 squares to factor this binomial. The expression a squared minus b squared can be factored as a plus b times a minus b. Therefore, the factored form is x plus 3 times x minus 3. Next up, we're going to factor this expression, this time using difference of 2 cubes. We know a cube minus b cube is equal to a minus b times the quadratic a squared plus ab plus b squared. I'm going to need some space, so I'm going to delete some of these. Following the formula below, the factored form of x cubed minus 3 cubed is x minus 3 times the quadratic x squared plus 3x plus 3 squared, or 9. The common factor of the left-hand side is x minus 3. X minus 3 divided by itself is 1. The second term divided by x minus 3 is x plus 3. The third term divided by x minus 3 is the quadratic trinomial. Rearrange the terms in this expression and combine like terms if possible. Write x squared first, and then x plus 3x, which is 4x. Also 1 plus 3 plus 9, that is 13. To solve this equation, equate the factor x minus 3 to 0 and to solve. X minus 3 equals 0. Easily, the value of x is 3. Since 2 raised to m is equal to x, equation becomes 2 raised to m equals 3. The next step is to take the common logarithm of both sides. Log of 2 raised to m is equal to log of 3. Recall that the power in logarithm expressions can be used as the coefficient. Therefore, m log of 2 equals log of 3. Divide both sides by log 2 to get m equals log 3 over log 2. Using the change of base formula, this is equivalent to log base 2 of 3. Note that this is just one of many possible real solutions. We aren't sure if this is the only real solution, so we just got to keep solving to find out. Apparently, we also need to equate this quadratic factor to 0 and solve, but before that, let's run the discriminant test to see if this has real solutions. In this quadratic function, the value of a is 1, the value of b is 4, and the constant c is 13. The discriminant formula is b squared minus 4ac. Substitute the coefficients. Therefore, discriminant is 4 squared minus 4 times 1 times 13. The result is a negative value, which means this quadratic equation has no real solution. Final conclusion? This is the only real solution of the equation.